Okay, good day. My name is Qwuiga from the University of Lagos, Department of Business Administration. Today we'll be looking at integration. The lecture outline, we'll be looking at the definition of integration. We'll be looking at why do we use integration. We'll also look at how do we identify an integration question, and as well, how do we solve a basic integration question, and as well, why do we introduce a constant. And the last, we'll be looking at integration of exponential. What is integration? Integration can be seen as the reverse of differentiation. Integration is a concept of calculus. It's the act of finding integrals. Under integration, we're always given a derivative which we are meant to find the original function. Why do we use integration? Integration can be used for finding quantities such as areas, volumes, displacements. As well, we use it in business to find some variables such as total costs, total revenue, profits, and so on. How do we identify an integration question? This symbol is an elongated S. Whenever this symbol is used, we have to carry out integration. How do we solve a basic integration question? For example, we have this. So, how do we solve a basic integration question? We have steps. Step 1, we increase the power of the variable by 1. And step 2, divide the resultant value of step 1. What do I mean? Okay. Step 1. We increase the power of the variable by 1. This carries 1 already. So we increase the power by 1. That's what step 1 says. So we have a square. Step 2, divide by the resultant value of step 1. We divide a square by the resultant value, which is 2. Step 3, we introduce a constant. Why do we introduce a constant? During differentiation, constants were regarded as 0. And don't forget that in integration, we're always given a derived value, which we have to find the original function. Let's solve another integration question. So how do we go about this? Don't forget, step 1 says we increase the resultant value by 1. At this point, to some students, this gives a lot of problem. But do you know I can as well express square root of x to be s raised to power 1 over 2. So this makes my work easier. So I'll have 1 over 2 plus 1. We should not forget that what step 2 says divide by the resultant value of step 1, which is the increased power. We have 4 plus 1 here over 2 plus 1 here over half plus 1. Step 3, introduce a constant plus c. So we have 5x raised to the power 5 over 4 plus 1, 5, plus 2 plus 1, 3, over 2 plus 1, 3, plus half. Here we find the LCM, which is 2. We have 1 plus 2 divided by 2, that's 1. We have 2 here. Very simple, just take this out. We have 1 over 2 plus 1. What is the LCM? 2. 2 divided by 2, 1. 1 times 1, 1, plus 2 divided by 1, still 2. 2 times 1, 2. 1 plus 2, 3 over 2. So we come back here. 1 plus 2, 3. Over here we have the same value, 3 over 2 plus c. Look at this variable here, can cancel this variable. 5, 5, 3 divided by 3, we have 1, 1, 1, 1. Then here as well, we have 1 over 2 divided by 3 over 2. So let's express it, let's write it out. We have x raised to the power 5 plus x raised to the power 3 plus half x raised to the power 3 over 2 divided by 3 over 2. I can as well express this form of division as this, then plus my constant. Okay, at this point we have to solve this. This is our major problem here. We have to simplify this. So we have x raised to the power 5 plus x raised to the power 3 plus, now this is, how do we do this? Now don't forget that to turn division to multiplication, then the numerator, the denominator changed to the numerator and the numerator turns to the denominator. So we have 1 x raised to the power 3 over 2 times, then we have 2 over 3. The changes have occurred, plus c. So we have 2 here 1, 2 here 1. So my final answer will be x raised to the power 5 plus x raised to the power 3 plus 1 over 3 x raised to the power 3 over 2 plus c. This is my final answer. So we'll be looking at another aspect, integration of exponential. For easy understanding, we can use this formula. The whole function over differentiation of the power divided by the log of the base. So let's look at an exponential question. We have integrate e raised to the power 7x minus 1 dx. So how do we solve this? Going by this formula, the whole function, what is the whole function? That is e raised to the power 7x minus 1. This is the whole function divided by the differentiation of the power. What is the power? This is the power, 7x minus 1. 7x minus 1. This is the power. So we differentiate the power divided by the log of the base. What is the base here? The base is e. This is the base, e. So what will be my answer? Don't forget, we have to introduce a constant. So my final answer will be e raised to the power 7x minus 1 over, we have to differentiate 7x minus 1. Let's bring that out. 7x minus 1. We have to differentiate this, that is, to find the function over the x. So this will be 7x. We have a power here, 1. We minus 1 from the power and multiply the power by the what? Base. So don't forget, this is minus 1. Differentiation of 1 is what? 0. So my final answer will be 7x raised to the power 0. X raised to the power 0 is 1, which is 7 times 1. 7. So my answer here as the differentiation of 7x minus 1 will be 7 divided by. So whenever we have the same base for a log, for example log 2, then my answer will be 1. So in this case, I'm having the same base with the variable here. So my answer here will be 1 plus c. Anything divided by 1, we all know it's still the same value. So we have e raised to the power 7x minus 1 over 7 plus c. Let us look at another aspect of exponential. For example, we have integral 10 raised to the power 5x minus 2. So let's look at this. Now, this is different from the other question we solved. Yes, we can have this. This is an example of an exponential. And please, an exponential not to be seen as a normal function. Other examples of exponential function include 2 raised to the power x, 5 raised to the power x, 10e raised to the power 2x. These are examples of exponential function. So how do we solve this? Going by this same formula, the whole function 10 raised to the power 5x minus 2. divided by the differentiation of the power. Divided by log of the base 10. The base here we identify to be what? 10. So let's move on. How do we differentiate this? We have 10 5x minus 2 over this will be 5x 1 minus 1 minus 0 when we were differentiating. So don't forget we multiply by the power. The power here is 1, which is 1. 1 times the variable is still the same result. It's still the same variable. So we divide by this. So what will be my final answer? I have 10 raised to the power 5x minus 2 over 5. Yes, 1 minus 1, 0. X raised to the power 0, it is 1. 5 times 1, that is how we get 5. That's how we got 5. So we divide by log e raised base 10. Okay? So at this point, we have 10 raised to the power 5x minus 2 over, let's take this out. How do we solve this? Differentiation. Multiply by the power 1 and subtract 1 from the power. Differentiation of a constant is what? 0. We have 5x raised to the power 0 minus 0. My final answer will be 5. X raised to the power 0, 1. 5 times 1, 5. So my answer here is 5. Divided by log 10. So we have 10 raised to the power 5x minus 2 over 5. So this, how do I convert divide to multiplication? Then I'll have 1 over log 10 base e. So my final answer, don't forget our constant. My final answer will be 10, this times this, 10 raised to the power 5x minus 2 over 5 log 10 base e plus c. I as well have questions for you. 10 probably raised to the power 2x minus 1 dx. Okay, I hope you guys have learned a lot. You can identify an integration question and as well solve an integration question. Thank you for watching. Don't forget to subscribe, turn on your notification button for new videos. Keep safe. Thank you.